for Module 7, Lesson 4, which is Rational Exponents. Okay, you should have 3 pages. 2.5 pages are notes, and then a half a page of practice. So if you were in class on this day, we did a warm-up, and it kind of reviewed Module 7, Lessons 1, 2, and 3, all combined into one question. Hopefully you were able to answer that and complete that in Canvas. All right, so Module 7, Lesson 4 notes. So this is the benchmark NSO 1.1, and we are still applying the laws of exponents to generate equivalent numerical expressions. And so let's first start with what is a rational exponent, and that's an exponent expressed as a fraction. So for any real number b and any positive integer n. So if I have a base of b and it's brought to the 1 over n power, I could rewrite that as a radical, which has an index of n, the radical symbol, and then the radicand of b. So let's take a look. Remember, when a lot of times you'll hear us say in class or hear me say in class that the bottom stays out and the top goes in. And what that means is I'm referring to the fraction as the exponent. So the bottom of our fraction becomes our index, or the small number outside of our radical, and the numerator of our fraction becomes our exponent. Oftentimes it's written underneath the radical, but you'll see here in a moment it doesn't have to be written underneath the radical. The exponent can also be in the parentheses. So here are all the parts of a radical. We have our index, or the nth root. We have our radical, which is the crazy looking division symbol, or some people refer to it as the check mark, but it is actually called the radical symbol. And then the number inside the radical or underneath the radical is called the radicand. All right, nth roots are just any real number a and b or any positive integer n. If a to the power of n is equal to b, then a is the nth root of b. So it doesn't really matter, it's just a vocabulary word at this point, so let's move on. Okay, we have 10 to the 1/2 power, and what we need to do is rewrite each expression in radical form, or if it's given to us in radical form, we're going to write it in exponential form. So 10 to the 1/2 power, we're going to write our radical. It's going to have an index of 2, because that's the denominator of our fraction, and an exponent of 1. Well, the 2 and the 1 are actually implied, so it would not be seen, and the way you would actually see it is just the square root of 10. And that's because there is an invisible or an implied 2 outside of that radical. There is no such thing as a 1th root, so it is not an implied 1 like you are used to with exponents or coefficients. Okay, so here we have the square root or radical of 7k. So if there is no exponent listed, it's an implied 1. So we would have 7k inside the parentheses to the 1/2 power. And yes, it must be in parentheses. Otherwise, the exponent only applies to the k and not the 7. All right. So here in example C, we have 2g to the 1/3 power. Here is what I was talking about previously. This exponent of 1 over 3, or 1/3, is only being applied to the variable g. So the correct way to rewrite this in radical form would be 2 cube roots, or 3rd roots, of g. That denominator became my index. And then finally, we have the 3rd root of 86. We could rewrite that as a rational exponent to be 86 to the 1/3 power. All right. Here are 4 questions that you can try on your own. Pause the video, try them out, and then come back and check your answers. All right. So just pause, watch, and try it on your own, and then come back and check. 34 to the 1/2 becomes the square root of 34. The square root of 5p becomes 5p in parentheses to the 1/2 power. 3x to the 1/3 power in parentheses becomes the 3rd root of 3x. And 6 3rd root of y becomes 6y to the 1/3 power. Okay, I'm just trying to help you understand what it is to be an equivalent expression so that you can go back and forth between radical form and rational exponent form. All right, we're going to continue on here with our lesson 4 notes, and now we're going to learn about principal roots. So when there is more than one real root and n, meaning the root is even, the non-negative root is called the principal root. So if I have 3 squared, and that is equal to 9, correct? Well, if I have negative 3 and that is squared, that is also equal to 9. So both 3 and negative 3 are equal to the square root of 9. However, the principal root, okay, that is 3 because that is the non-negative root. So yes, the square root of 9 could be negative 3. However, the principal root of 9 is 3. So here we're going to evaluate each expression. So we need to find the third root of 8. Well, the third root of 8, we need to first find the factors of 8. What are all the things that multiply together to give me 8? Well, 8 is 2 times 4, and 4 is 2 times 2. So if I'm looking to figure out what the third root of 8 is, well, guess what? 2 times 2 times 2. So I have 3 2's. If I multiply all those together, I get 8. Because my index is 3, I now know that the third root of 8 is just equal to 2. Okay, so now I'm going to look for the fourth root of 81. So first thing I'm going to do is find the factors of 81. Well, most of you would tell me that 81 is 9 times 9. Those are the easiest factors for you to think of, I'm guessing. So 9, the factors of 9 are 3 times 3. And the other factors of our other 9 are also 3 times 3. So the fourth root of 81, I could rewrite to be the fourth root of 3 times 3 times 3 times 3. And because I have 4 of the same number and I have an index of 4, what that means is that I could take it out and it becomes 1, 3. Well, also, if I have negative 3 times negative 3 times negative 3 times negative 3, that is also the fourth root of 81. So the fourth root of 81 has 2 possible answers, but the principal root here is 3 because that is the non-negative root. All right. We didn't have to worry about the non-negative root for A because it had an index of 3. We only have to worry about principal roots if it has an even, if our n or root is even. 4 is an even number, 3 is not. All right, the third root of 64, x to the power of 3. So I'm going to write this 64 in expanded form, or basically factored form, which is 4 times 4 times 4, okay? Times x times x times x. If I multiply all those together, I would get 64x to the power of 3. I am looking for the third root of this. So I have 3 4's. I can take it out. It becomes 1. I have 3 x's. I'm going to take it out. It becomes 1. So the third root of 64x to the power of 3 is 4x. 243, if I factor that out, happens to be 3 times 3 times 3 times 3 times 3. I am looking for the fifth root of 243, which happens to just be 3. And if you are questioning my math skills, you can go ahead and type this into a calculator. If you have the TI calculator at home, you can use that. Otherwise, you can go to desmos.com and use their scientific calculator. And so the fourth root of 625, p to the power of 4. Well, 5 times 5 times 5 times 5 is equal to 625. And p times p times p times p is equal to p to the power of 4. So that simplifies to be 5p. Here I did have an even root of 4, so I do have to label that as my principal root. Oh, wait, I do not, because there's actually 2 factors, so there are no other roots because it would simplify to 5p, because a negative 5 times a negative p would equal to a 5p. And then finally, we have the sixth root. Again, that is an even root. But because I have 2 and r, it could not be a negative 2r because a negative 2 times a negative r would give me a positive 2r. So the only root possible here, again, is 2r. All right, try these checks on your own. Come back, see if you have the correct answer. The third root of 125 is equal to 5. The fourth root of 1,296 y to the fourth is 6y. And the third root of 1,000x to the power of 3 is 10x. Okay, finally, we will be evaluating exponential expressions with rational exponents. And so here we have 27 to the 1/3 power. That is also equal to the third root of 27. And the third root of 27 could be rewritten as the third root of 3 times 3 times 3, which is just equal to 3. 343 to the 1/3 power is the third root of 343. So that is 7 times 7 times 7, and the third root of 7 times 7 times 7 is just 7. Finally, in order to do example C, we need to find the fourth root of the numerator and then the denominator. And so the fourth root of the numerator is 3 times 3 times 3, and the fourth root of the denominator is 4 times 4 times 4 times 4. So that simplifies to be 3/4. Finally, you're going to try 8, 9, and 10 on your own. Pause the video, come back and check your answers. All right, the fourth root of 16 is 2. The fifth root of 100,000 is 10. And the 8 over 125 to the 1/3 power, you would rewrite as the third root of 8 over the third root of 125, which simplifies to be 2/5. All right. So how am I doing this so fast? Well, 729 to the 5/6 power, you have two options. You could rewrite that in radical form with an index of 6 and an exponent of 5. But I would recommend just evaluating this on a calculator and typing in 729. You would use the y to the x button above your division symbol. 5, use the ABC button, which is your fraction button on the left lower side of your calculator. 6, and hit equals, and you would see that it is equal to 243. Similarly, if you had 36 to the 3/2 power, you're going to do 36 to the 3/2 in your numerator, 36 to the 3/2 in your denominator, and you would get 216 over 343. And then you're going to try checks 11 and 12 on your own. Use your calculator or your Desmos calculator. And when you do, you should get the answers 343 and 6/7. All right, here's your practice problems. Go ahead and try those in Canvas or on the paper, and I will see you tomorrow.